If space is falling towards Earth, then the Michelson-Morley experiment should yield a null result, which it did. Our assumption matches the result of the experiment. Rotating the experimental setup left and right should have no impact on the results, and it didn't. Michelson was also part of another experiment known as the Michelson-Gale-Pearson experiment. This experiment was intended to measure Earth's rotational velocity at the surface. The setup is shown here. Light entering in corner A is split, with one beam going clockwise and the other one counterclockwise. Due to Earth's spherical shape, the rotational velocity is not the same for all latitudes, with latitudes closer to the poles rotating slower than latitudes closer to the equator. In the setup, light takes longer to go from left to right than it does from right to left. The difference is greater in the lower latitudes because of the higher velocities. The experiment included a bypass path very close to the starting point to be used as reference against the longer loop. The experiment was a success, and Earth's rotational velocity was measured with an accuracy of slightly greater than 2%. It speaks volumes of the genius of Mr. Michelson to continue doing experiments despite his previous results. He produced another way of measuring Earth's rotational velocity. This is the way we want science to work, different methods giving us the same results. There is no disagreement between the different ways of measuring Earth's rotational velocity. The importance of this experiment is that it ties together time dilation effects due to motion with the results of an interferometer. The time dilation effects experienced by orbiting satellites can likewise be measured with an interferometer. It has been proposed that this setup is similar to the Sagnac interferometer. The Sagnac interferometer has a split beam going in opposite directions in a rectangle made up of mirrors. Light travels the same distance and it takes the same amount of time in either direction. When the setup is rotated, light circulating in the same direction as the rotation takes a longer time as it tries to catch up to the mirrors than the light in the opposite direction. This results in a change of the interference pattern. Most modern optical gyroscopes are based on this principle. Looking at the Michelson-Gale-Pearson experiment, you can see the similarities. Let's modify the setup such that the mirror on corner D will reflect the light back to corner A, and the mirror on corner F will also reflect the light back to corner A. We can take this whole section out. This is now the original Michelson-Morley configuration. It does not change the fact that light takes longer to go from A to F than from F back to A. You can see that the interferometer works as intended. It also tells us that the speed of light is not constant for all frames of reference. At the very least, this is an effect that should be considered when measuring the speed of light. The original Michelson-Morley experiment, with arms of only 11 meters, did not have enough sensitivity to measure the motion that was present. This is different from saying that there was none. Some scientists claim that the reason why this works is because objects on Earth's surface will follow a circular path as Earth rotates. This is not a good explanation. Earth's orbit around the Sun is also somewhat circular, and so is the Sun's orbit around the galaxy. A circle is a circle regardless of the size of the diameter, and whether it takes 1 day, 1 year, or 230 million years to go around it, it is still a circle. If you have ever heard an explanation for relativity involving a train on Earth's circular surface, claiming that the speed of light is the same for all, let's just say that it's hard to see how we can reconcile that claim with this experiment. Let's go back to the original Michelson-Morley experiment, and let's run the experiment as Michelson and Morley did, to measure Earth's motion in space. As we rotate their setup, the instrument is not detecting any motion. It reads a velocity equal to 0. If the velocity is 0, then the time dilation should also be 0. We use the Lorentz transformation equation to determine the time dilation, and there is none. Dilated time equals non-dilated time. We can now go back to the GPS constellation and remove vectors for the Earth's orbital motion, and the Sun's gravitational time dilation. They do not exist. For the GPS constellation, there is no time dilation due to Earth's orbit, nor solar gravitational time dilation, nor time dilation due to the Sun's motion, nor the galaxy's motion. What the Michelson-Morley experiment tells us is not that the speed of light is constant for all frames of reference. What it tells us is that Earth's velocity through space as it goes around the Sun is equal to 0. Earth's gravitational field, creates a space bubble around Earth. The bubble moves around the Sun. Inside the bubble, space moves toward Earth. Objects orbiting Earth will only experience time dilation due to their orbital velocity and due to space moving through them as it falls to Earth. Nothing else.